Okay, now I did ask you all to send me some emails with any questions you might have. And one of you sent me an email with questions from the old test from chapters 1 and 2, Spring 2000, version B. And the question in the email had indicated that the student who sent this in and worked them out had gotten different answers than the answers I had on the key. Now, it is quite possible that sometimes you'll find the answers on the key to be not correct. I haven't looked at these closely at this point, and I'm going to look at them closely right now with you in this video. So number 2 on this old test said give the next 3 terms in the sequence. 2, 5, 10, 17, blank, blank, blank. Okay, this is assuming that the established pattern in this sequence continues in the same manner that it's going on for the first few terms. So what I'm going to do is I'm looking at the difference from 2 to 5, that's plus 3. Then from 5 to 10 is plus 5. And from 10 to 17 is plus 7. Assuming that the same pattern continues, I would expect from 17 to the next number to be plus 9, and from that one to the next term, plus 11, and then finally plus 13. So the pattern being that the jump each time increases by 2 numbers from the previous jump. I'm going to use my calculator for this simply because I'm having to check an answer that's on the answer key, and I don't want to make the same mistake that I might have made 16 years ago when I did the answer key to this test. So I'm going to put in 17 and do plus 9. So my next term, the first blank, should be 26. 26 plus 11, I get 37. And 37 plus 13 gives me 50. So that's the answer I would go with. Now, if you look at the answer key, you will see that the answer on the answer key is incorrect. So sometimes that happens. Sometimes you have to be careful about, keep that in mind. Sometimes you might be looking for a mistake, and when in actuality the mistake is on the answer key. Number 10 on this same old test. Find the number in A if the number in B is equal to 23, the number in the intersection of A and B equals 9, and the number in the union of A and B equals 39. For this problem, I need this formula that we went over in class the other day. The number in the intersection of 2 sets would equal the number in one of the sets, A, plus the number in the other set, B, minus the number in the intersection of the 2 sets. So there's my formula. I will fill in what they gave me in the problem with the proper numbers. The number in A union B is 39. Now the number in A, this is what we're looking for. And you could keep it as the number in A. I've had a lot of students in the past just say, well, I'm going to call that X, since they're used to that from algebra classes, and it's just a little bit easier to write than the number in A. Okay, so I got that, X plus the number in B. The number in B is 23, minus the number in the intersection. The number in the intersection is 9. So I'm going to do this. I'm going to combine the like terms on the right side. 23 minus 9. And again, since I'm wanting to be careful and I'm checking to see if my answer is wrong on the key, I'm going to go ahead and use my calculator. 23 minus 9 equals 14. So 39 equals x plus 14. And the next step, the final step, is to subtract 14 from both sides. And instead of subtracting by hand, I will use my calculator. 39 minus 14 is 25. So I get 25 equals x. This gives me that the number in A equals 25. If you look at the answer key, I had the wrong answer. I hope this helps, and keep sending in those questions.